All right, last unit test upcoming in the semester. We are going to take a look at the Unit 3 review, do some things here to make sure you got all the right answers and a little confidence going into this one. We're going to start simple. Again, when we're simplifying, notice it's plus and minus in between. It's not multiplying. Do not add the exponents. Just combine like terms. So when we're doing this, so 9 plus 4 would be 13x to the fourth. Again, don't mess with those exponents. This is my only x squared term. 7 minus 6 is 1. And 2 minus 9 is negative 7. No other like terms. I'm done. Keep it simple. On B, suggestion. Remind yourself that that's distributing through. That's changing the signs on every single term in the second set of parentheses. These are being left alone. So now I've distributed, now I can just combine like terms. 15 minus 4 is 11x to the third. Negative 8 plus 7 is negative 1x. And negative 11 minus 2 is negative 13. Okay, again, off and running. When I get to my function notation, again, these are labels. This is what f of x is. Find f of negative 4. All that means is you plug in negative 4 every place you see an x. I'm not multiplying by x. Okay, I'm not going to multiply through everything by 4. I'm literally plugging that in for the x value. And whether you do that in your head, you punch it into the calculator, whatever it happens to be, that's where my solution's coming from. And the same thing even works if you have a variable term. So here, this is going to seem a little strange, but I'm going to plug in 2a everywhere that there's an x. Now here's the kicker on this one that you have to be careful of. That cube not only goes to the a, it also goes to the 2. So 2 cubed is 8. 8 times 9 is 72. A to the third. Again, don't multiply these first. What's in the parentheses? 2 squared is 4 times 2 is 8. A squared. And then negative 4 times 2 would be a negative 8a. Don't take anything out. Don't try to factor. Nothing. You plugged in the 2a. You've simplified it. You're done. So stop. Okay. Our story problems, our profit functions. NHS is selling handmade scarves for a fundraiser. Revenue is given by R of x is 16x. That's how much they're selling for. They're not selling for NHS. They're not selling for a fundraiser. Okay. The profit function is always my revenue minus expenses. Revenue minus expenses, but be careful. You have to subtract all of the expenses. If you forget the parentheses, that 120 is going to mess you up because I've got to distribute this through 16 minus 4.5 is 11.5x. And that negative distributes to the 120. So that would be my profit function. The profit on 60 scarves, as long as I got my profit function right, I'm just going to plug that in and get my value out. But again, it's critical that when you're doing these, that you're cautious with your negative. So then when we continue with our function notation, again, write the expression. The x here is a label. And when I say a label, what I mean is this is f of x plus g of x. Doesn't mean I add them together and then multiply by x. It just means f of x, 4x squared plus 2x minus 3, plus g of x, x plus 1. Okay, nothing to distribute. There's no other like terms to look at anywhere else. The plus doesn't change anything. So now I just combine what's alike. And I'm done. don't make this harder than it has to be. F times g of x. Now I know some of you like doing this just with distributing, which is fine. Some of you like doing that little box thing. So like if you were going that route, maybe you could set this up this way, and then you're just multiplying the sides to fill in the box as you go. Now don't just leave it all in the box. I still need to combine like terms. But my like terms will be in a nice diagonal for me. But notice I'm not messing with my exponents once the box is full. Just combine like terms and I'm done. Now there's a slight difference when we go to the next part. Now we're doing function notation, which this again means this is f of g of x. In other words, I'm going to take g of x, this x plus 1, and I'm going to plug that in every place that I see x. So it's going to look something like this. And please don't get sucked into just distributing this and calling this x squared plus 1. You've got to FOIL this part out. So on this one, if I FOIL that out, separate these, I get x squared plus 2x plus 1. So again, it's x plus 1 and x plus 1. I'm going to go ahead and leave the rest of this for a second. I'm going to clean this up. Distribute my 4 through. And it's worth the time to take your time and not try to do multiple steps at once. That's where you make the silly errors and lose lots of half points. And now I can finally put together my like terms, and I'm ready to roll. But you have to understand what's being asked for. If those were switched around, if it was g of f of x, I'd be plugging f into g's x. So the order does matter. The second one is the one you're plugging in. And finally, we haven't talked much about domain restrictions because typically those are only fractions or even roots. Well, I haven't seen any even rooted exponents. I've seen even exponents, but not even rooted ones. And fractions, well, we're about to get into a fraction here. This isn't factorable, and I can't start wiping x's and things. The pluses and minuses, again, are strong bonds that can't be broken unless things are identical. But I do have an issue here. My domain, my x values, I do have a restriction this time. This can't equal 0, because if it equals by 0, that's undefined. So x cannot equal -1 is a restriction for that expression. And I need both. If I only have one or the other, I only got half the answer. And then finally, for this section on 8, we have f and g of x. What is f minus g of 8? Now, I have choices here, but here's the choice I normally make. I go ahead and I plug the 8 into each one to make it simpler on me. So, for instance, here, I'd have 3 times 8 squared minus 8. So I'd have, let's see, 64 times 3 is 192 minus 8 would be 184 minus g of 8 is 8 minus 7, which is 1. Subtract my 2 answers and I'm good to go. So don't make life complicated. Okay, if they give you a number, plug it in. More function notation, p and q of x. Find p times q of 3. But again, they give me a number. If they give me the number, take advantage of that. So I'm like, okay, so p of 3 would be 2 times 3 minus 4. But notice its absolute value. 3 minus 4 is -1. But what's the absolute value of -1? It's 1. So 2 times 1 is 2. Q of 3 is 7 minus 3, which is 4, and multiply them together. The big thing here is remembering that you have an absolute value. Here, Q of p of negative 4. Well, what's p of negative 4? Negative 4 minus 4 is negative 8, but what's the absolute value of negative 8? Positive 8. So 8 times 2 makes this q of 16, and then I just plug in the 16 there. 7 minus 16 is negative 9. So it's lots of little things here that can get you if you're not being careful. So I come to the next one, find the inverse. Remember, f of x is a fancy way of saying y. To get the inverse, I switch the x and the y, and then I solve for y. Well, since I'm multiplying, if I multiply both sides by the reciprocal, the negatives cancel. 3/2 times 2/3 is 1. And I get y equals negative 3/2 x. Once y is solved for, I'm done. And it's the same thing working on 12. Switch them. Don't multiply yet. Get it isolated before you do. So I'm going to add the 14 over. And again, do not divide by 7/2 and put x plus 14 over 7/2. Nobody writes it that way, and I'm willing to bet that if I put the actual answer up next to it, you wouldn't even know they were the same thing. So what I want to do here is multiply by the reciprocal. And if you want to leave it as 2/7 x plus 14, you can. If you want to distribute it out, you can. But if you do, make sure it goes to the x and to the 14. Because if it doesn't, you just turned it into the wrong answer. So switch x and y, solve for y, done. More function notation. Okay, basically here, find g times f of x. G times f of x. Distribute. And we're good. Just the little stuff. G minus f of x. Make sure to take it in the right order. Minus all of f of x, not just the 7. Distribute. Combine like terms. And we're good. And again, if I get going too fast sometime, you can pause me. You can rewind me. It's nice. Okay. And finally, 15, we're just doing g plus h. So look for like terms. X and negative x squared cancel out. 3x, negative 2 plus 8 is plus 6, and I'm off to the next page. Okay. So take enough time to make sure you're careful on things, but don't overthink these things, because it'll take up time and it'll also technically probably get you to mess something up. Find f of g. F of g. In other words, we're looking for f of x plus 3. Plug in x plus 3 where x is at. 5x plus 3, and distribute. Second one is always the one being plugged in. G of f, g of 5x. Plug in 5x where x is. 5x plus 3. It literally is going in for that. Not times, in. Okay? And then a couple more with functions here to really hammer it home. Okay, k of x is square root of x. H of x is x minus 64. K of h of 100. So k of h. So stick in 100 in the h. 100 minus 64 is 36. And then stick that in. Square root of 36 is 6. I'm good. So for some of you, I really think putting that extra step in like this would help. Oh, I'm plugging 100 in for k. Square root of 100 is 10. And then it's like, oh, okay, well, this isn't so bad. So this would be 10 minus 64, which is negative 54. And I'm done. Like, all right, this ain't so bad. Inverse of f. Yeah, I'm going to have to do a little work here. So I'd have x equals 2y minus 5 over 3. Get that fraction out of there. 3x equals 2y minus 5. Add the 5 over. And divide by 2. Okay, and it does actually set up that way. I didn't break it apart. So that's what that one would look like. And so we just keep seeing the same types of things with all of them. F of g of 2. F of g of 2. Plug in 2 into the g. 5 minus 4 times 2 would be 8. So 5 minus 8 is negative 3. Plug the negative 3 in here for x. 2 times negative 3 is negative 6. Plus 3 is 3. And I'm good on that one. Now, did I do something silly? Yes, it's negative 3, Harty. Details. Those are the things that end up costing you points. If you're not careful, I should have written it out myself. I will on the next one. You're like, wait, I can plug something into itself? Yes. If I plug in negative 1 for f, 2 times negative 1 is negative 2, plus 3 is 1. And then I just plug that 1 in for x. 2 plus 3 is 5. And I'm good. Okay. Prove whether these are inverses. So you plug one into the other, and you should get an answer of x at the end. If you don't, so here f of g, I'm going to plug g into f. G into f. And over here, I'm going to plug f into g. So what should happen here, once I actually finish them off, because again, it's just the x that's being replaced by the other function. I should simplify this, and when I simplify it, I should get a solution of x back. Because if they're inverses, that's what you get when you find the composition of one into the other. And I do, and I'm proven. So that works out kind of nice. Okay, 2 examples of functions whose inverses are also functions. Now here, notice 2 examples of functions. A regular function has to pass the vertical line test, whose inverses are also functions. Horizontal line test. So you could come up with several different things that are going on here. Could do something as simple as a line. But you have to watch for other things that you do, because for instance, maybe you go with a parabola, but maybe it passes one test and it doesn't pass the other one. But again, remember, you're going to sit and go, well, wait a minute. So you're telling me if I do this, you're like, well, that'd pass the horizontal, but it wouldn't pass the vertical. But remember, when you found this inverse would end up reflecting into something like this, and it would pass the vertical, okay? You've got to understand that the inverse is going to be a different graph. It's not doing the same test on one graph. So both of these would be absolutely good for this. So it passes the horizontal line test for this, because that's how we test for an inverse on these. Okay? So again, got to be careful on those. 23 is going to work similar, the same way 21 did. F of g means g is going into f. Replace the x with 4x plus 12. For g of f, f is going into g. Replace the x with my f function, and I should get x at the end. 4th of 12 is 3, minus 3 is x, good. 1/4 of 4 is x, minus 12 plus 12 is x. And that proves that they're inverses. If I get anything but x, like x plus 2 or some value, it doesn't work. And if one doesn't work, they both don't work. We're just about to the halfway point here, so when we get to the bottom of this factoring section, we'll cut off this first video and then start up with the second one. So here, when we go to factor, again, this is something you have to have a grip on. If you don't, you've got to go back to the notes, you've got to go back to the book, you've got to go back to the videos on the website. Don't let little things freak you out, like, oh my gosh, it's x to the 4th. Don't think of it that way. We've talked before about when you see something with an even root, like to the 2nd or to the 4th, you can treat it like it's 16x squared minus 49, or 49y squared. Hopefully at this point you look at those and you go, oh, those are perfect squares. And it's true. Because the difference of squares, if this were the problem, it'd be 4x and 4x. And 49 is 7 and 7. And again, y squared means there's a y on each of them. But x times x is x squared. What times what is to the 4th? Squared and squared. That's my factorization. But I have to know what a difference of squares is. If I see 4 terms, again, we had that note sheet where we broke each of these down. What do I do if there's 2 terms, 3 terms, 4 terms? Those are the types of things you've got to have. Or go back on the website and find the notes if you've lost them somehow. What do each pair have in common? Got to get the biggest thing they have in common. No numbers, but they both have an x squared. So to get from x squared to x to the 3rd, I need an x and that 2 in front. Here I need the 3, but I've already got the x squared. Don't need any more. Now if I've done this right, when I do the second pair, I'm going to have the same thing here. These, I don't see a value, but I see they both have a negative. So I'm going to take a negative 1 out of there. Negative 1 times positive 2x would be negative 2x. Negative 1 times positive 3 would be negative 3. And then you put back together your greatest common factors. And one of those, but be careful. Sometimes, on rare occasion, like this one, you may have your greatest common factors and then put together a breakdown again. That's a difference of squares. So those are the little things that you've got to watch out for. Because if you stop here, you'll just get a little bit of a ding, but it's still a ding. Okay. 26, I see a cube, which gives me a hint. What do I cube to get each of these? X to get x cubed, 4 to get 64. And then I run that pattern we've talked about, and you've got to know the pattern. The 2 terms with the same sign in the middle. Square my first term. If there was a number with it, I'd square the number 2. Change the sign of what you started with. Multiply those together. Square your last term. Done. So you've got to watch for these things. 27, same thing. Don't let the 4th get to you. Treat it just like it's x squared minus 12x plus 27. Use a diamond. You go, okay, so use a diamond. X and x. What multiplies to 27 and adds to negative 12? Negative 9 and negative 3. But these are both x squareds instead, because 2 plus 2 gets me to 4. But again, be careful. Do either of these break down? Sure. Difference of squares. Like anything else, it takes practice. Play with more in the book if you're still having issues. And get those knocked out. But the one thing we haven't talked about yet with factoring, which I can't believe I let 4 problems get by and I haven't said anything about the golden rule, but that's got to be what you think about first here. If all of your terms have something in common, okay, I can take a 3 out of all. Keep looking. They all have x's and it's not just x. You always take the smallest exponent you see, 3x to the third. So now whatever I multiply 3x to the third by to get each term back is what's going to go on the inside. I already have the 3. 3 to get to 5, I need 2. 3 times negative 8 is 24. 3 plus 1 is 4. 3 times 12 is 36, and I already have the x to the third. Don't be content. Can I factor what's in the parentheses? Well, let's see. X and x. Multiply to negative 12 and add to negative 8. Now let's think. It would be negative times negative, because it's either 2 pluses or 2 minuses to get this, but I see the minus in the middle. 6 and 2. That worked. Okay. So I've got to keep working away at this. 29. Same idea. They're both cubes. You've got to be able to recognize your cubes at this point. If you're still having issues and you're wondering, is that a cube or not? I'm not sure. Here's how you can kind of, I'm not going to say cheat, but you can fudge it a little bit. Take your value, and if you can take it to the 1/3 power, because remember, it's exponent over root. My exponent's 1, my root is 3, so I'm looking for a cubed root. You also can get it that way if you happen to forget if that's a perfect cube or not. And of course, you can do it with squares by square rooting it. So once I have that, I'm going back to what I was doing here on 26, except the sign in the middle is different. So I start with the minus. Then I, as I talked about in 26, square the first term, the 3 and the x, not just the x. 3 squared is 9x squared. Change the sign. So if you start plus, it goes minus. If you start minus, it goes plus. Multiply those together and add, and we're good. So again, we're looking for patterns. We're looking for clues like cubes or squares. We're looking for greatest common factors. 6. Do all 3 terms have an A? No. Do all 3 terms have a B? No. All I can get is the 6. Whoops, don't need that one. Now before you circle it again, they're like, oh, are you kidding? This one's going to factor 2? Again, if you see something that frightens you, look at it like a normal diamond. Forget the second variable. So I look at this and I say, okay, got A and A. If this were the problem, it would be -1 and -1. And the only difference now is I pop a B on each one. Don't make life difficult. I'm factored. I'm good. And again, as I keep doing these, with anything in life, the more you practice it, the easier it gets. What do these two have in common? They both have an x squared. 2 and 1 get me 3. I already got both my x's. I just need the 2. Here, I don't see anything else in common, but they both have a negative. I'm going to take the -1, which changes the signs on both of these. If I distribute, I get this back. And some of you are like, oh, it's just like 25. It's x squared -1 again. You're right. So I'm going to do the same thing. I'm going to factor that and then get my answer. Don't sweat it. 32, just like 24. A fourth is like dealing with squared terms. If this was 25x squared minus 81, you said it'd be 5x and 5x. 9 and 9 and a plus minus, but it's not x squared, it's x to the 4th. So instead of 1 plus 1 is 2, it's 2 plus 2 is 4. And 5 is not a perfect square, so I actually don't have to break something down for once. Woohoo! And then finally down here, again, back to like 27 was, treat this like it's x squared minus 10x plus 24. Just use a diamond. Both negative or both positive? Both negative. 6 and 4. But again, it's squared. Do I have to break anything else down? Are either of those a difference of squares? You're darn tootin' it is. X squared minus 4 is x plus 2, x minus 2, x squared minus 6. Woo! Okay, so the first half of our video on the review is done. No, your test itself will not be this long, but I wanted to get you multiple opportunities to practice on things. Part 2 will be coming, so if you have an issue on numbers 34 here through the end, which is going to be 60, those will be done on the second part of this, so stay tuned.